Okay, so we're going to be looking at the internet topic in digital technology. I'm going to do a blitz to show how everything is linked together. So we've got the internet, and we've got the 4 phases. So I'm going to do 4 phases. And that's going to be like our main bubble. Coming off it, we've got phase 1. Which is all about connectivity, which is all about digital access to info. We then got let's do phase 3 down here. Let's do phase 2 here. In fact, let's call this phase 4, just because I'm going to go downwards quite a lot. You'll see why in a second. And over here we'll do phase 3, which is basically the network economy for phase 2. The networked economy, so this is where e-commerce starts to come into play. So it's for digitized business processes which come in. E-commerce, the digital supply chain, etc. We then got phase 3, which is the collaborative experience. What this is about? It's all about digitized interactions. So linking business and social media. So this is talking about mobility, social mobility, like working on Zoom. This is talking about cloud, social media, videos, etc. And then we've got our next phase. I cannot move. I don't know why. There we go. But now I can't move my stupid pen. So phase 4 is the Internet of Everything, where we literally, it's known as the digitize the world, connecting. So the Internet of Everything is what we're looking at the most. This is how it brings all technology together. But it brings it together with, I'm going to do some subcategories down here. People. In fact, let's do that in a different color, just so that this is clear. We've got people. We've got the process. We've got data. And finally, things. So the Internet of Everything is broken down to 4 different parts. People, process, data, things. So if you look at people, people refers to customers who want a service. Makes sense? It also refers to the companies trying to provide a service. So, right now, we've got this is a point, and this is a point of people. Process is all about how we gather data. So it's about gathering data. It's also about the most important thing, processing data. It's not just about gathering, we need to do something with it. So gathering data, processing data. We then have data itself. We need to understand data, i.e. turn it to information. Understand data so it can be used. The idea is, what we want to do with data is make it meaningful. Turn it into information. So it's how we turn data we collect, like how many mails are using a website, and turn it into information so that we can actually do something about it as a business. We've then got things. These are physical objects. These are examples: mobile devices, smart devices. Let me just move this across a little bit. Tablets. All of these devices, let me just move it across slightly more. So all of these physical objects process data, collect data, analyze the data, let me just neaten this up. And interact with user and internet and other data-based services. Okay, so let's have a look at things in a little bit more detail. So, oh man, why is my mouse being weird? 1 second. There we go. Let's talk about things then. Well, we know that things are physical objects. These physical objects, let me just have a path coming up from this one, use sensors. They use processing ability, so like a microprocessor. They have software, and they have other tech. And what things does, the whole point is, it exchanges data over the internet or another communications network. So, for example, your phone connecting to your speakers using Bluetooth is a network. You'd have to use the internet to do that, but it's still a network. It doesn't have to be internet connected. Now, things doesn't always have to. So a thing basically can communicate. I'm going to use the word com for communicate. So it can communicate with each other with or without. I'm going to go out of space here. I'm going to change the color of the pen. Human interaction. So a thing can, so let's say a smart car can interact with a parking sensor, and it doesn't need a human. They talk between each other, or it needs a human to say, let's do this, such as Alexa or Siri. Okay, so let's have a look at the definition of things and a little bit more information. So let's just go down. We said that they're physical objects, but they could also be, I'm going to put or. So physical objects, or also known as machines, or interactive devices, or assistive devices like Alexa. So these are known as, so things are known as physical objects, or machines, interactive devices, assistive devices. Now everything requires a unique ID, identifier. Let's just do identifier. It also requires an embedded system like a CPU, and the ability to transfer data over internet. So a thing has a unique identifier, embedded system. It should be able to transfer data over the internet. Now, in order for it, when I say internet, I'm also going to say network, because we said it doesn't just need to use the internet. The unique identifier for it to be able to connect to a network, it needs to be using IP version 6 due to IP version 4 not being good enough anymore. Why? Well, we're at the limits of IP version 4, so we've got more address space due to it having 32 bits, which is 4 billion addresses. Oh, okay, so this is IP version 4 versus IP version 6, which is meant to have trillions of addresses. And that is due to basically having 128 bits for IP version 6. Due to this, 5G networks can grow or expand. And 5G networks are what smart devices and assistive technology rely on. So let's have an overview so far of everything. We have 4 phases of the internet: phase 1, phase 2, phase 3, phase 4. Phase 4 is the internet of everything. Internet of everything is made up of 4 things: people, processes, data, and things. If we zoom in on things, we know that the physical objects, mobile, smart devices, and tablets, they can communicate with or without human interaction. We know that the whole point of these physical objects is that they're made up of other technology, software, sensors, and processor ability. We know that they're there to analyze data, process data, collect data, or interact with users and the internet and other database services. We know that the whole point is for them to exchange data over a network or the internet. We know that physical objects could also be known as machines, interactive devices, or assistive devices. We know that each thing needs a unique identifier, an embedded system. So we've mentioned already embedded system up here with processing ability. So I'm going to do a link. How do I change the pen color? Let's see. There we go. So let's do a link between, what was it, embedded system and processing ability. There we go, there's a link there. So we know that things also require a unique identifier, which unique identifiers would be IP version 6, because IP version 4 doesn't have enough bits for enough addresses, which then stops 5G from growing, which is what these devices rely upon, because 5G networks have an advantage over other Gs, such as we looked at in that whole topic. So this 5G, you will need to use your knowledge of what 5G is all about and why it brings an advantage for technology to run faster or greater bandwidth. And think about greater bandwidth, more devices can use the internet networks. So the internet of everything will grow. Okay, so let's look at this again with a slightly more detailed outlook about things. Let me just change my pen color. There we go, it's purple, right? Okay, so let's take things. And what we're going to do is we're going to move and create a new branch out here. And the reason why is there's a lot we need to cover still about things. And that is that, to begin with, we've got our smart devices. Now, these smart devices can be used in different contexts, such as the home. We've got the built environment. And we've got manufacturing, 3 key areas. Okay, so we need to be aware of the following things. Each one of these aspects has advantages and disadvantages of where they're going to be used. And we'll talk about these 3 aspects individually in a bit. But before we do, we need to also be aware of legalities of smart devices, and these legalities, or shall we can put legalities / ethics. So we've got health and safety, we've got Employment law. Are we taking people's jobs? We've got data privacy. Potential issues. We need to be aware that smart devices have grey areas like with data privacy, like how much data is Alexa storing, what does it store, where does it store it, where's search, what phrases does it recognize and use, health and safety issues in the workplace if we're using smart devices, what happens if something fails, like a smart temperature control, which is there to keep employees healthy, cool, and it doesn't work, then what happens? And it becomes too hot for workplace. Employment law, whose roles are being replaced. So we need to be aware of those different aspects. But going back to smart devices and their different uses, or should we say context, we've got the home, where you need to be able to give examples of things like smart speakers, smart TVs, smart fridges, smart watches even. You've then got the built environment, such as smart heating, smart lighting, and smart parking, and more. Smart traffic lights is another one. Manufacturing. You've got Industry 4.0, you've got smart scanners, smart glasses like AR. Remember, the home is literally things you can have inside your house, but they're not built into your house. The built environment could be in your house. So there's a relationship between the built environment and your home. There's a relationship between the built environment and manufacturing. But the built environment is anything which is physically built, put into a building, which can then manage that building itself. So smart parking is built into the parking lot. It can then manage the parking lot efficiently. Smart heating is built into a home or an office. It can then change the temperature of that building. Manufacturing is, remember, producing something, making something. You need to be aware of Industry 4.0, smart scanners, smart glasses. Okay. Now, if we're looking at smart devices, we need to know how or what hardware is used to build them. So we need to be aware that there's a relationship between smart devices. Let me just bring this back. There we go. And here are the tech, software, sensors, processing ability, because remember, smart devices are physical objects, they're things. But we need to be able to understand how it all works. So we need to be able to understand, let's say for Alexa, how Alexa is a smart device, how Alexa would use a smart speaker, how Alexa, with their smart speaker, has inside of it a microphone, as well as something allowing them to connect to the internet. We need to be aware that with Alexa, what happens is there is a continuous signals sent to speaker or speaker's central system. So if I have Alexa in my house, constantly there's a signal going to it all the time. Inside the central system, it uses pattern recognition software So it uses pattern recognition software to match signal received to the keywords / commands like "Hey Alexa." So you can give an example. This software, by the way, is AI. So, with Alexa, smart speaker has inside of it a microphone connecting to the internet feature. You get a continuous signal sent to the speaker's central system, which the central system is a processor and software. The software uses AI to use pattern recognition to match the signal to keywords and commands. It will then act upon it. So it'll do an output. That's its output, by the way, based on this. So, with smart devices, we've got that by using home built environment manufacturing. We need to be aware of the legalities and ethics, health and safety, employment law, data privacy issues. We've given an example of how smart devices are using other tech, software, sensors and processing ability, such as with using Alexa. Alexa's smart speaker with microphone and connecting with internet features, blah, 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 blah. We now need to be able to talk about with smart devices the advantages and disadvantages, or shall we say the positives and negatives of using them. By the way, when I say signal for Alexa, that signal is sound waves. Okay, so let's move, and we're going to create a new link for smart devices for positives, and then obviously negatives. So the positives, we've got increase automation. We've got, these are plus signs by the way, higher productivity, and efficiency. We've got cost saving. We've got increased direct comms. So by using smart devices, our communication goes up. And we've got instant data access. You could argue that the bottom 2 points, so increased comms and data access, is why it's more efficient, but whatever. The negatives, there's concerns around privacy and security. You could have device compatibility issues. Trying to get lots of different smart devices to work together could be a challenge. You need an increase in network complexity. Let me just move this down. Ugh. What is going on? Sorry, 1 second. Pause. Okay, so where was I before this whole thing went apart? We're talking about an increase in network complexity. We've also got people becoming more tech dependent. So these are all, or a range of, shall we say, positives and negatives to do with smart devices. But let's go back to the legalities and ethics aspect. We spoke about the legalities and ethics slightly, but actually we can put a little bit more detail into this. So we need to be aware, for example, of the impact when it comes to legalities, or shall we say ethics, that smart devices have on professionals. So I'm going to add professional impact needs to be considered, i.e., will this change industries? By using smart devices, which leads to people just being consumers or delivery drivers. Because manufacturing, for example, has been taken up by smart devices, which means it doesn't need humans, which means that there's a change. So instead of it being human consumer, actually let's say organization which wants to make something, you have humans which make it with machines, and output of goods, those goods are then delivered to the consumer. By having smart devices, will that get rid of the human aspect in the manufacturing? It could also get rid of the delivery aspect as well. So again, whilst it may have some advantages, it could change the industries as well. People have to find new jobs. Instead of people being delivery drivers, you have to be the guys who program the smart devices or control the smart devices to deliver items like drones, for example. So it's changing industries professionally. Then we've got aspects such as, especially with AI and smart devices, bias AI data. So Alexa, a smart device, uses AI. Is there an issue around bias there? So is there a situation as well when we talk about data privacy that Alexa could recognize individuals? So if I go to someone's house and I start talking, Alexa goes, "Oh, it's you. It's you, Asher. How are you?" So it recognizes me. Then should have law enforcement, should they have access to this data? So all of these are different types of ethical issues, legal issues, data privacy, employment law, health and safety. There's acts around this, like the Data Privacy Act, etc. But remember, you need to perform your own research and use the lesson resources and material, etc. to deepen that understanding even further. We then got not just legal issues, but we also have environmental issues. Those environmental issues could be related to manufacturing, which is linked to disposing goods. This will look at 5G and what that could do to the environment, like power masts and stuff like that. We could talk about electricity costs. So disposing goods, about recycling, etc. How does that be impacted by technology? And we've got also a finite resource. It's not infinite. All of them doesn't always grow back, or doesn't grow back at the rate of what we need. So all of these are environmental issues. So if we were to zoom out, this is everything to do with, so far, the Internet of Things. Sorry, before basis of Internet of Everything, we went to things. We looked at what a thing is, we looked at how you connect, we looked at the identifiers, we looked at 5G, we looked at then examples of smart devices, we looked at Alexa, how Alexa works, we looked at the home, the built environment, manufacturing, and keep notes about all of this are big questions. These are big topics: built environment, manufacturing, and the home. We've also got the legalities and ethics. We've also got positive of smart devices, and we've got negatives of smart devices. We've also got further ethics and big data bias and AI bias, and we've got professional impact of using smart devices. We looked at the environment as well. So we're now going to look at the final thing for the Internet of Things, and that is going to be the positives and negatives of the impact of the Internet of Things. So I'm going to create a new little line going through here and going through here. And this is going to be looking at IoT positive impact and IoT negative impact. So we can talk about effective comms and IM, instant messaging services, as positive. But we can also look at, from a negative perspective, social networking, disturbing personal and professional life. We can then look at another positive: increase business interactions, saves time. Think about it, I don't need to travel anywhere, I can do everything at home, so travel time goes down. We could also talk about, as another positive, if it turns these into pluses: less complicated banking. Think about PayPal transactions and shopping. But a negative, you could argue, stealing data, so data interception and hacking. IoT devices is easy if you know what you're doing. But a positive: access latest news. Let me just move down. Anywhere in world. Negative: using internet to spread bad scenarios or fake news using IoT easy. Positive. Online courses. Let's just set online courses on virtual assistants online. So you can do loads of online courses anywhere in the world. Negative. Easy access of age, inappropriate or unsuitable let me just move down and info. Positive. Professionals have IoT devices in healthcare, education, e-commerce, and AI with these devices helps jobs become easier. So we've got overall so far, we've only got one final thing to do with this whole topic. We've got our Internet of Things, so we've got our 4 phases of Internet, we've got our Internet of Everything, we've got the Internet of Everything made of different things, people, places, data and things or objects, blah, 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 blah. We looked at all the different examples, what they are, smart devices. We then looked at the legalities of smart devices, environmental and manufacturing. We looked at smart devices being used in the built environment, home and manufacturing, which is a big question. We looked at how Alexa works with the different components. We looked at the fact that everything is made up of sensors, unique identifiers, embedded systems, so it's got processing ability, etc. Software, so Alexa's got software for AI. We then looked at the legalities, ethics, we looked at the positives and negatives of smart devices. We then looked at the positives and negatives of just the Internet of Things impact. Now this last thing, I'm just going to do a few screenshots and put it on. And that is basically for Internet of Everything. Let's make a new little branch. Let's move to the left. 3 main impacts of IoE. And you've got the following. We have people to people, where you need to be able to talk about retail, manufacturing, public sector and service providers. Let me get the next one. We also have machine to people. Well, again, we've got the retail, manufacturing, public sector and service providers, which talks about the connections and their impacts. And finally, zoom out, we've got machine to machine. So let me just sort this out a little bit and let's zoom in. With machine to machine, have a look at the different sectors, look at the different connections, and then look at the impacts of each different sector. So that's machine to machine, people to people, and machine to people. Just a note that the Internet of Things impact of positive and negative is also a big question. So that is the topic of the Internet of Everything.